my camera button working? Here we go. We'll start with this one. I think this is the one that you have listed first as well. Okay, perfect. Make it a little bit smaller so it's not quite so big. Still pretty big. There we go. So we have in red here our basic graph. And we notice that on our basic graph, they've labeled one point with a dot. They've labeled 16, 4. And what I want to look at is, do you see that each of these has numbers in front, outside of the function? That's going to affect the y value. And what we're going to do for each of these, starting with the blue one, we're going to say, what happens to 16, 4? If I have a 3 out in front for my blue graph, what did we notice with our parabola? It multiplied your y-coordinate. You're going to multiply your y-coordinate by 3. Where do you end up then? 16, 12. Do you notice on the graph that that's the point that they've labeled? 16, 12 on the blue one. When I go to my green graph, I take that original point that I had, 16, 4. Now, I have a 2 in front of my equation. That 2 is outside of the function. It's going to affect my y-coordinate. What's going to happen to my y-coordinate? It's going to get multiplied by 2, telling me I should have 16, 8. Sure enough, that's the point that's labeled. Ooh, we got to use some fun colors. Orange, 16, 4. Now I have a fraction out in front of a half. I'm going to multiply my y-coordinate by a half, leaving me with 16, 2. Sure enough, that's the point labeled on that graph. And finally, with the 1/4 in purple, I started with 16, 4. I'm going to multiply my y by 1/4. It's going to give me 16, 1. And that's the place or the point that's labeled on that graph. So this is exactly as our getting started. We noticed that if it's outside the function, it affects the y value. And everything that's happened outside of our function has always been what our gut would tell us. We're multiplying by 2 outside. I'm going to multiply y by 2. If you have plus 4 outside after, what did we do? We moved it up 4. Now we're going to look at what happens in the middle, or if it's inside. So I'm going to take this picture. There we go. Make it a little bit smaller. And again, we're starting with our basic graph, and the point that they labeled here was 4, 2. And we're going to start with the blue one. Do you see that there's a 4 inside your function? Does it make sense that that 4 would be inside? Okay? So in the blue one, we're going to say, what happens to 4, 2? It's going to affect my x-coordinate. And this is where things that happen inside sort of go against what your gut feeling is. Remember when it was plus 3? Your gut feeling said, I want to move it 3 to the right, but it was actually 3 to the left. The 4 inside here is going to make you want to multiply x by 4. But instead, you're going to multiply x by 1/4, which is technically the same as dividing by 4, but we're going to always write multiplying by the reciprocal. So I take 4, do the reciprocal, which is 1/4, and I multiply by that. When I multiply my x-coordinate by 1/4, I get 1, 2. On my green graph, I see a 2 inside my function. My gut wants me to multiply by 2, but anything inside is a bit opposite. So you're going to multiply by the reciprocal, 1/2. Multiply your x coordinate by half. You get 2, 2. And the reason we say multiply by the reciprocal is because when you get to fractions like the orange one, so here I start with 4, 2, I have a half inside. I'm going to multiply it by the reciprocal, 2/1. That's why it's 8, 2. And finally, our purple one, the 1/4 inside means you're going to multiply your x coordinate by 4/1. Which gives you 16, 2. And what I'm doing on the right-hand side with the points, we're going to start doing more of that. As we add more things that you need to do, you're going to show your work by saying, this is a point that's on my original graph, and this is what I have to do to it. Like, I have to multiply my x values by 2, so I can show my work here to see where that point goes. With moving left and right and up and down, it was easy just to see where it would go. But when you do more things, you're going to have to start to show some of your work. And that's what happens in the third one here, where they put both of them together. Did I hit the wrong button? Or is it just frozen? Nope, it just frozen. So again, the point on the original graph is 4, 2. If we start with the blue graph, what happens to 4, 2? Well, we look. Can you see that there's a 4 on the outside and a 2 on the inside? Putting those two together, you're going to multiply y by 4 and x by 1/2. What happens to that point? X by half is 2, y by 4 is 8. Sure enough, that's the point that they've labeled here. Can you see that all of them are going to keep 0, 0? Because if you took 0, 0 and you multiplied y by something and multiplied x by something, you're still going to have 0, 0. But what's going to happen for you later on is it's not going to be enough just to find out where one point goes. You would have to try maybe 2 or 3 points to graph this. You would take 4, 2. Maybe you'd also use 1, 1, and most importantly, 0, 0, because that's where the square root graph would start. But for right now, for just starting to understand this, we're just looking at one point. So in the green graph, what would happen to 4, 2? Well, I've got a 2 on the outside. That's going to multiply my y values by 2. I have a 2 on the inside. That's going to multiply my x values by the reciprocal, 1/2. Y by 2, that's going to be 4. X by 1/2, that's going to be 2. Does that match up on the point that they have? Yes, 2, 4. 2 more to go. The orange one. What happens to 4, 2? Now we have a 2 on the outside. Y is going to get multiplied by 2. We have a 1/2 on the inside. Means that x is going to get multiplied by the reciprocal, 2/1. And finally in purple, the half on the outside means that y is multiplied by half. The half on the inside means x is getting multiplied by 2. And we're going to get 8, 1. So again, everything that happens on the outside is kind of what you would expect. But everything that happens on the inside is a little bit different. With left and right, it was the opposite direction. With stretches and compressions, you have to multiply by the reciprocal. So you have to flip your answer. Okay, so we're going to skip to now to example 1. They give us the graph of f of x in function notation, and we want to graph the graph of y equals negative 1/4 f of x. And then finally state the domain and range of each function. So the first thing I want you to notice, can you see that it is outside the function? That negative 1/4 is outside the function. And then I might make a note here. I'm going to take my y values and multiply by negative 1/4. So for showing our work, well, we're going to have to take some strategic points from our first graph and see where they go. Most importantly, we're going to have to figure out what happens to 0, 0. Because that's sort of like the vertex of this absolute value. That's a very important point. Now, I'm going to choose some other points. Okay? Are you okay that I choose 4, 4? Why might I not want to choose 1, 1 or 2, 2? It wouldn't be wrong. But there was strategy involved, like I think 4, 4 would be a good choice. Another good choice, I think, might be negative 8, 8. That would be a not bad choice. They're factors of 4, because we know that we're multiplying by negative 1/4. So it makes nicer numbers in the end. It's not wrong to choose 3, 3, but if you chose 3, 3, you'd have to multiply 3 by negative 1/4, and you're going to have not as nice a number to graph. So as far as my work shown, I've picked 3 points on my original graph. I'm going to draw an arrow to show that it's changing. And above the arrow, I'm going to say what I'm going to do. In this case, I'm going to multiply y by negative 1/4. That negative showed up there. So then all my x values are going to stay the same. They're still going to be 0, 4, and negative 8. But my y values could change. So while 0 times negative 4, that stays 0. 4 times the negative 4, sorry, 4 times the negative 1/4, negative 1. And 8 times the negative 1/4, negative 2. So on my new graph, I'm going to have 0, 0. I'm going to have negative 8, negative 2, and 4, negative 1. Okay, I'm going to make the mistake that I think each of you wants to make. You ready for this? 4, negative 1. How many people did that point already themselves? Yeah? And that's wrong. Why is that wrong? It's going by 2s. Can you see yourself doing that? Going, oh, I'll just count down 1? Like, why do they make it by 2s? So that would be right there. And negative 8, negative 2 would be right there. Now, describing what's happened, can you see that the red graph has been flipped? And we would say this one has been compressed vertically. squished towards the x-axis. Does it look like someone sat on that absolute value graph, flattened it a bit, and then flipped it over? Okay. Question, reading it again, it does say state the domain and range of each function. I'm going to use set notation this time. So domain, it gets wider and goes forever, so it's everything. The range, the red graph does have a smallest value and goes up forever, so I can say y is bigger than or equal to 0. For my blue graph, the domain is still everything, but my range now doesn't have a smallest value, but it has a biggest value at 0, is less than or equal to 0. Okay, we're going to try question number 3, but before we do that, okay, everything in this question was written in function notation. So I'm going to add a question to this. And the question that I'm going to add is, can you write the explicit equations for each graph? Now, explicit equation is no function notation, it's just with x's. So the red graph, did you recognize it? What kind of graph was the red graph? It was one of our, from the sheet that we had. It's the absolute value. So the explicit equation for the red graph would be this. Okay? Now our blue graph, we were told in function notation, our blue graph was -1/4 of f of x, and f of x was the original graph. Can you see that the explicit equation for the blue graph then would be, oh, there's a -1/4 in front of the absolute value of x. So this question was a little bit easy for us because they gave us the original graph and then said, could you graph the blue graph? Okay? But on your exam, sometimes they'll just say, here's the equation, -1/4 absolute value of x. Graph it. And you would have to know what absolute value of x looks like to begin with, know the 3 points that we chose, that I'm going to choose 3 points, and then be able to figure out what the new graph looks like after that. Okay, I'll let you work on question 3 and any of the other questions from before if you still have